Hey everyone, today we're going to be talking about the final way to solve for systems of elimination, systems of equations. We've talked about solving these by graphing, by substitution, and now the third and final way is elimination. So I'm going to go through these notes pretty quickly, but feel free just to pause them and jot them down. As always, they're probably not going to make a lot of sense at the beginning, but we're going to do a couple example problems where we follow these steps step by step. So in systems of equation elimination, the main idea is that we are eliminating a variable from the system. We're actually going to have a variable drop out by adding and subtracting. So the first thing we want to do is stack your equations, making sure the variables line up. Number two, we're going to add or subtract the equation so that one variable drops out. Then we're going to solve for the variable that is left over. And lastly, we're going to plug, just like with substitution, we're going to plug in the value of one of the variables into the original equation to solve for the second variable. Okay, so again, get these notes down. They're probably not going to make a ton of sense right off the bat, but we're going to do a couple of practice problems where we follow these steps. Okay, so again, feel free to pause, but I'm going to move on. Our first example problem is this right here. We have two equations, and as always, we're trying to find a solution to these equations. We're trying to find an X and a Y value that work for both this equation and that equation. We've done it with graphing and substitution. Now we're going to do it with elimination. So my first step when I am doing elimination is I'm going to stack these equations on top of each other, but I want to make sure that my variables line up. And right now, since we're just starting out, they're going to line up pretty easily. So let's just start out with this one. It doesn't matter which one you start with. 2x plus 5y equals 17. And I'm going to take my second equation, I'm going to stack it right underneath it. And my variables are already in the same order. So you're going to see how they stack up nicely. 6x minus 5y equals -9. That's an equal sign. Okay, so number one, done. We've stacked up our equations, making sure that our variables line up. My x's line up, my y's line up, and my answers, my constants over there line up as well. Now, the goal of this is to have one of these variables drop out. We're literally going to stack them up and either add or subtract these variables in this order as if we were adding or subtracting a multi-digit number. But we need to think about, hey, should we add or subtract? Now, I'm seeing some matching coefficients right here with my y value. I got a 5 and a -5. And remember, the goal is to have one of these drop out. So if I end up adding these two variables, I know that a +5 and a -5 are going to drop out. So this is like saying 5 plus -5 gets me to 0. That's what we want for 0y, so that y drops out. So I'm going to use addition in this problem to have my y's drop out. It's not always going to be addition. The next problem is going to be subtraction. But think about, always be thinking about, should I be adding these or should I be subtracting these? Now, the y's are going to drop out. This is like saying 0y if we're just thinking about this column here. But we got to do the same thing for everything else. So we're going to add 2x and 6x. We're just going to look at the coefficients. 2 plus 6 is 8x. I had 2 x's, then I added 6 x's. Now I have 8 x's. Nothing's happening here with the 0y. That's what we wanted. It's actually going to drop out. But we can't forget about our answers over here on the right side. So this is like saying 17 plus -9. A lot of these problems is really going to challenge your integers ruling, meaning really thinking about adding and subtracting negative numbers. What's that going to look like? So always think about, what am I doing over here? I'm adding. So this is like saying 17 plus -9. If you need to write it off to the side horizontally, that's totally fine. 17 plus -9 is 8, positive 8. So that's what I'm going to write down here. Okay, so let's clean this up. The y drops out, so I don't really need to write that, but I wanted to show you that that's what's happening, is that the y is dropping out. It's being eliminated. So I'm left with 8x equals 8. And I'm done with number 2. I have added and subtracted these equations and had a variable drop out. Now I'm just left with one variable. If we have one variable in our equation, we can always solve. So we're going to solve for the value of x by following our steps of SAD-MEG. And really, we don't even need to do SAD-MEG. We just do one step, which is to divide everything by 8. So my 8's drop out. And I'm left with x equals 1. So we figured out the value of x, that is 1. So we've done number 3. Now number 4 looks very similar to substitution in the last concept, where now that we know one of our values here, we can plug it into one of our original equations and solve for the other one. It does not matter which equation you plug x into, just pick one. Let's pick this one because it looks like I have some more positive numbers over here. And if I can avoid negative numbers, that's what I'm going to do to avoid making a mistake. So this is step number 4. I'm going to start with 2x plus 5y equals 17. I know what the value of x is, so I'm going to plug that in here. That is 1. So it's going to be 2 instead of x, it's 1 plus 5y equals 17. Let's clean this up. 2 times 1 is 2 plus 5y equals 17. Now I'm just solving for an unknown using SAD-MEG. I'm going to take 2 away from each side first, because that's what SAD-MEG calls for. 5y equal, so my 2's dropped out. I'm left with 5y. 17 minus 2 is 15. Final step is to divide by that coefficient 5 so that the 5's drop out. And I'm left with y equals 15 divided by 5 is 3. I've got my x value. I've got my y value. Now I can just come up with my solution. 1, 3 is my solution. And there's my answer for this problem here, the solution 1, 3. Yeah, no problem. Just a video, just a math video on YouTube. You're going to be a part of it now. Okay, so my solution is 1, 3. I am done with this problem. Yeah, let's do another one where we're going to use a different operation than adding. And that is going to be what are we going to say? Let's say 3x plus 3y equals -9. And 3x minus 4y equals 5. Cool. So first step, we need to stack these up, making sure that our variables line up. Lucky for us, they're in the similar, very similar order. So let's do that. It doesn't matter which one you start with. Yeah, it doesn't matter which one you're going to start with. 3x plus 3y equals -9. And let's put this one right underneath it, making sure our variables line up. 3x minus 4y equals 5. Okay, so you need to start thinking about some matching coefficients, because that's going to be the key to our elimination here. They need to be matching coefficients. Whether they're positive or negative is a different story. And that's what we're going to be talking about in this problem. But I'm seeing right off the bat that I have matching coefficients right here. They're the same number, 3x, 3x. So 3 is my coefficient. So that's going to be the one that I want to drop out because they have matching coefficients. The 4s, the 3 and the -4, they're not going to drop out right away. we're going to end up solving for them. But so let's focus on the three x's because they have matching coefficients. Now, if I add this problem, these two equations, like I did in the last one, I'm going to end up with 6x. They're not going to drop out. So instead of adding, I'm going to use subtraction for this problem, and I'm going to subtract all of these terms. And you'll see that if I do 3x minus 3x, I end up with 0x. I have eliminated the x term, which is what we want to do. Now, because it's substitution, we really got to think about how this is going to affect the other numbers in a negative or a positive way. So next down the line is the 4. I've got a 3y minus a negative 4y. So if I wanted to rewrite that horizontally, please do. So I got a 3y minus a negative 4y. And you should recognize that this is a double negative. So this is going to turn into a 3y plus 4y, which is going to give me 7y. So again, from this, I got a 3y minus a negative 4y. I end up over here with a positive 7y. And then my last term, a negative 9 minus 5, negative 9 minus 5. Well, that's just going to give me negative 14. My signs are the same, so I find the sum, and I got more negatives than positives. Cool. So that was step number 2, where we have eliminated, we have added or subtracted the equations so that one variable drops out. This x drops out. We're done with it. Now all we need to do is focus on this y and solve for y. We're going to do that by dividing by 7 in this case. So my 7's drop out, and I'm left with y equals negative 14 divided by a positive 7 is a negative 2. Again, there's a lot of negative signs in these elimination problems, so please make sure you are paying attention to the negative signs. So I'm on number 3. That was number 3. Number 4 is plugging this y value into any one of these equations and solving for x. Let's just pick this one. It does not matter. You could pick either one. I'm saying this is step number 4. I got 3x plus 3y equals negative 9. I'm going to plug in a negative 2 for y here. Get 3x plus 3. Instead of y, I got negative 2 equals negative 9. Let's clean this up. 3x positive 3 times a negative 2 is a negative 6. So I'm going to say minus 6 equals negative 9. And now we are ready to use SAD Meg. We're going to add and subtract first. So I get the 6's out of there. I got 3x equals negative 9 plus 6. That's a negative 3, keeping track of my signs. And the last step, I'm going to divide by 3, divide by 3. X equals negative 3 divided by positive 3 is negative 1. There's my value for x. There's my value for y. So my solution is negative 1, negative 2. Because remember, I do x, then y. Negative 1, negative 2. That's all I got. Thanks for watching.